Hello everybody, this is a remake of the user instruction video for the Advanced Timing Pulley Generator. I had to remake the original video because the add-in has changed quite a lot. The first version of the interface was becoming too cumbersome with too many inline parameters. The UI has now been reworked around tables and grouped controls, which makes the workflow much cleaner. In this tutorial, we will walk through the Advanced Timing Pulley Generator workflow from start to finish. The same general workflow applies to both the metric T and AT generator and the imperial MXL-XXH generator. The main difference is the unit system and the supported pulley profile families. To start the add-in, first make sure you are in the Fusion 360 Solid workspace. If the command icon is visible on the toolbar, you can launch it directly from there. Alternatively, go to Create and the pulley generator should appear in the list. If the add-in is not on the list, it is probably because it is not running. To start it manually, go to Utilities, then Add-ins. Find the pulley generator in the list. Make sure Run at Startup is ticked or enabled, and then use the Run option to start the add-in. If you have to come here to run the add-in, I recommend ticking Run at Startup first before clicking Run, because once you click Run, this dialog box closes. Here, I have just turned it off, so I'm going to run it again and show what happens. The dialog box closes. After that, the add-in should now appear in the Create list. If it is still not on the list, you may need to restart Fusion 360. Once Fusion 360 has restarted, the add-in should appear in the list. Clicking the add-in opens the command dialog with the default options. The add-in is divided into several tabs. You have Main Setup, Pulley Groups, Spoke Style, Layout, Generate, Settings, Advanced, and Output. The Main Setup tab defines the overall architecture. First, choose the mode. The add-in can run in simple mode or advanced mode. Then choose the design type. This can either be single pulley or two pulley layout. Next, choose the relationship between main 1 and main 2. There are three options: manual tooth count, equal tooth count, and ratio. Manual tooth count means you manually set the tooth count for the second pulley. Equal tooth count means main 2 will always match main 1. Ratio means you enter a ratio, and the add-in calculates the tooth count for the second pulley. I will set the ratio back to 1 so the two pulleys are the same size again, then return to manual tooth count. In two pulley layout mode, we also have idlers. In this case, the idlers are mainly used for tensioning and layout planning. They can be placed on the inside of the belt or on the outside of the belt. When idlers are enabled, the solver places them in the open space between the pulley bodies. This keeps the idlers visually centered between the two main pulleys, even when the pulleys are different sizes. For example, if I switch back to ratio mode and change the ratio, the pulley sizes change, but the idlers still stay positioned in the usable space between the pulley bodies. So let's go to the next tab, Pulley Groups. The Pulley Groups tab is where the pulley profile is set. The tooth profile is normally the same for all pulleys because they all ride on the same belt. The exception is when the idlers are set to outside belt. In that case, the idlers contact the smooth backside of the belt, so their final generated surface is smooth rather than toothed. There are several options to choose from when it comes to the tooth profile. The metric generator includes T profiles from T2.5 to T20 and AT profiles from AT3 to AT20. Here, I can set the tooth count and choose the belt width. I'm going to change the belt width to 10 millimeters. When the belt width changes, the actual pulley thickness also changes in the preview. For example, if I change it to 25 millimeter, the pulley becomes wider in the preview. If I change it back to 10 millimeter, the pulley becomes narrower again. Next is the bore, which is the shaft opening size. This value can be set independently for the active pulley groups. There are a few shaft styles available: round shaft, square shaft, and D shaft. With the round shaft option, there is also an option for a keyway. When the keyway is enabled, the keyway controls become active and the preview updates to show the keyway. When the keyway is turned off, the keyway controls are grayed out and the preview returns to a plain round bore. The next shaft style is square shaft. For the square shaft, there is an option for corner fillets. If I increase the fillet radius, the corners of the square opening become rounded. If I reduce the fillet radius back to 0, the square opening returns to sharp corners. When I switch back to round shaft, the square fillet option is disabled. The third shaft option is D shaft. With D shaft selected, the bore shape changes to include a flat side. The keyway D shaft depth field controls the depth of the flat. If I increase the value, the flat moves deeper into the bore. If I return it to the default value, the flat returns to its original position. Below the main controls, there is a millimeter summary of the selected pulley group. This is especially useful in the imperial version of the add-in, where the editable input values are in inches. Here, under Selected Group Controls, the first row shows the inch values, and the second row shows the equivalent values in millimeters. This makes it easy to compare the editable inch values against the metric reference values. Next is the Spoke Style tab. Spoke Style defines the spoke or cutout preference for each pulley group. The Style column selects the spoke family. The Detail column chooses between auto values and custom values. The Result column shows the current solver outcome. In auto values mode, the solver calculates the geometry automatically based on the available space. In custom values mode, the spoke geometry controls become editable. If a row is not used, the controls remain visible but disabled, and the preview switches to the not used state. There are several spoke styles available. Auto allows the add-in to choose the result based on available space and predefined rules. Solid means there are no spoke cutouts. Standard spoke creates straight spokes from the outer region toward the inner hub. Angled spoke creates angled spoke cutouts. If I switch the angled spoke to custom values, I can modify the spoke angle directly. In this case, the default value is 12 degrees. Let's see how far it can go. So 25 degrees is too much. Let's try 20 degrees. That is still too much. Let's see if we can adjust the number of spokes. By changing the number of spokes to 3, the 20-degree angle becomes valid. With 3 spokes, 25 degrees also works. Can we do 30 degrees? Yes, 30 degrees works as well. For this example, I will leave the value at 15 degrees. That is the angled spoke option. Tapered spoke creates a spoke shape where the geometry changes between the hub side and the rim side. Circular cutouts create circular openings in the pulley web. If I increase the feature count, the number of circular cutouts increases. When custom values is selected, the spoke controls become available. Hub margin controls the distance between the shaft or hub area and the inner side of the spoke cutout. If I reduce the hub margin, the spoke cutout moves closer to the shaft. If I increase it, more material is preserved around the hub. Rim margin controls the material preserved near the outer rim of the pulley. Reducing the rim margin moves the cutout closer to the toothed rim. Increasing it leaves more material near the rim. Spoke width controls the width of the remaining spoke material. Increasing the spoke width makes the spoke material wider. There are also fillet controls for the hub side and the rim side. These round the internal corners of the spoke cutouts, which can be useful for printed parts. If I switch back to auto values, the add-in automatically resolves the spoke geometry again. Next tab is the Layout tab. This is where the pulley layout is controlled. Here you can choose the belt length by setting the belt tooth count. If I change the belt tooth count, the belt layout changes because the belt pitch length has changed. You can also adjust the idler relationship, including whether the idlers are on the inside or outside of the belt. The idler offset changes the idler position and affects the solved belt layout. For example, if I increase the offset, the idler position changes and the belt path updates. The idler tension allowance is different. This moves the idlers as a tensioning allowance, but it does not solve a new belt length in the same way. So this parameter should be used carefully because it is more of a user-applied tension adjustment. Then there is the Generate tab. This controls what will actually be generated. You can choose whether to generate the main pulleys, the idlers, or only selected representative parts. If the two pulleys have the same tooth count and settings, generating one representative pulley may be enough. If the pulleys are different, I recommend generating both. If you need to do any animation or layout checking, it is usually better to generate the full pair so the model matches the mechanism more clearly. This tab also controls layout sketch creation. Moving on to the next tab, which is the Settings tab. The Settings tab collects default settings and behavior options. Profile Management handles import, export, and reset. Shared Defaults contains the flange sharing option. Preview and UI behavior controls the live preview and interface behavior. Preview mode can be switched between 3D geometry preview, 3D wireframe preview, and 2D preview only. The 3D geometry preview gives a realistic view of the pulley, but it is heavier. The Include Spoke Preview Geometry option creates realistic spoke cutouts in the preview, but this feature is experimental and may make the UI less responsive, so it is disabled by default. "3D wireframe preview is lighter. 2D preview only is the simplest and fastest option. These preview options are useful when performance becomes an issue. Auto Switch to Error tab can also be enabled. When this is enabled, if an error is created while changing values, the add-in can switch to the tab where the error needs to be fixed. This makes it easier to find the problem without hunting through every tab. The Auto Spoke Solver section controls how automatic spoke margins and spoke widths are calculated. It includes settings such as auto margin percentage, minimum web policy, cap modes, and auto spoke width factor. These settings are live. If I change the auto margin percentage or spoke width factor, the result table, and preview update immediately without restarting the command. The cap options prevent the automatically calculated margins from growing beyond predefined limits. The Advanced tab is mainly used for pulley tolerances. It is shown by selecting Advanced mode from Main Setup or by switching to the Advanced controls directly. The tolerance engine allows clearance and profile offsets to be applied to the pulley groups. This is useful when adjusting the pulley fit for real belts, 3D printing, material behavior, or manufacturing process. The Output tab gives the approximate results and dimensions for the generated pulley or layout. If there are warnings or errors, they are also shown here. The feedback area at the top of the dialog gives short operational status on every tab. Small issue counts appear directly. Larger issue sets are compressed into a summary and point you to the Output tab for details. Functional errors highlight the tab where the problem can be fixed. If I reduce a value too far, the add-in gives a warning or an error. A warning means generation may still be possible. When the issue becomes a full error, generation is blocked. For layout problems, the preview can show the invalid layout in red instead of simply disappearing. This makes it much easier to understand what failed. The Output tab also shows where the issue is coming from, so you can go back and correct the value. Once the setup is valid again, the warning or error clears. Before closing the tutorial, I will generate a few example pulleys. I will create one more example. This time I will use a tapered spoke style. Again, I can leave the solver on auto values or switch to custom values if I want direct control over the spoke geometry. After checking the preview and confirming there are no errors, I press OK again. That gives us another pulley style, this time using tapered spokes. At this point, that is really what the add-in is about. It lets you generate timing pulleys automatically, while still controlling the important details such as profile, tooth count, belt width, bore type, flanges, spokes, layout, and tolerances. That is the core workflow for the current release of the Advanced Timing Pulley Generator. The aim is to remove the repetitive work from pulley creation while still giving enough control over the engineering details. Thank you for watching.